Hi, this is Bill Punch from Michigan State University. This is another video in the series of videos on the topic, the practice of computing using Python, CSE 231. We're going to continue our examination of how to make classes be consistent by using standard methods. In particular, we're going to now use introspection to get things like commutativity to work. Let's go ahead and get started. So let's look at our clock class. This is a clock class we had from before. Let's go ahead and define it. And then let's try to do some things with it. All we're going to do is make a new clock and then try to print the clock plus an integer value. And in this case, what we'd assume would be true is this integer value is going to represent another minute or an integer minute that we're going to add to the clock to try to make the clock bigger. And if we do this, we get an error. It's an attribute error. And interestingly, it seems that if we just reverse those two things, same idea, integer minute added to a clock, but reverse them to be commutative, also an error, but a different kind of error, a type error. So first of all, it doesn't work, and second of all, just doing the commutative operation doesn't work either, gives us different errors. So we want to examine that to see if we can figure it out. Let's look at the first case. The first case is when we do an add of the kind we just talked about, C1 plus 1 on the right-hand side. C1 goes to self, and the integer 1 goes to this right-hand side clock. When we get to this expression, the right-hand side clock dot hours, that's when we get our attribute error. The integer does not have an hours attribute. We need to check the types. We need to introspect when we bring this parameter in to make sure it's the right type and do the right thing. What we want to do is make a new clock that has the appropriate number of minutes, and here's how we can do it. What we'll do is we'll bring in the isInstance operator, and we'll check to see if the right-hand side clock is an integer. If it is, then what we want to do is call the constructor. We want to make a new clock. Right-hand side clock is the parameter integer that came in. That's why we got here, 0 hours. Construct a new clock by calling the clock constructor. Reset it back to the variable right-hand side clock, and the rest of this stuff works just fine. If we do that, we evaluate those changes in our class, and we run the first example, C1 plus 1, we get what we wanted. So 1 plus another minute gives us 1 2. The if statement checks the type, converts it to a clock, and does the fine addition. However, that doesn't check or solve our second case, 1 plus C1. Why is that different? It really has to do with the mapping that we do. We remember that when we do 1 plus C1, that actually maps to the first element, calling an associated method with an argument of the second type. And the integer 1 does not have an add method that's associated with C1. We would have to insert one of those, and that simply isn't possible. We don't want to change Python's code. It would be bad if we changed. It would be burdensome, many things. And so Python provides a way around it. And the way around it is it defines these special operators. For every add operator, there's an R-add operator. For a sub operator, there's an R sub operator, where the R stands for reverse. And rather than tell you, let me show you what will happen. Let's say we make the call as we said. We try to do a 1 plus v2. That maps to 1 underline, and that's a fail. What Python says is, look, let me try the following thing, see if this helps. I'm going to switch the arguments for you automatically. Sure, the order was 1 plus v2. I'm going to switch it around for you. I'm going to see if you have an R-add method. Call that is reversed add method, and see if you have that. If we have, we'll run that. What does the R-add method have to look like? It doesn't have to do much. Take a look. Here we are in the R-add method. This is now mapped to the v2. This is mapped to the integer, and we know that if that's the right order, all we really need to do is call the add method that we already have defined and return its value to see how it goes. Now what I've done in this particular class to update it is I've put at various places the print statement. So every time one of these methods is called, it tells where it was when it called it, so we can follow the sequence of things a little more easily. Let's go ahead and define the class. Let's go ahead and make a clock, 1 in 1 as before. Print it, add it one way, add it the second way. With those print statements stuck into the system, this is what we get. So when I operate this statement, I'm in the constructor. When I make the call, I then print the result. That's a call to the string operator 101. Here we are. I'm calling the add operator because I have an integer. I need to construct a clock out of it. That's the call to this constructor. When I add them all together, I create a new clock. That's a call to that constructor. I return the results. I have to print it. That's a call to the string operator 102. Here's the more interesting one. If I do it reverse, I said Python would reverse things and call things as I indicated. So this is a call to radd. My radd calls the add function. Convert the 1 to a clock. Return the result as a new clock, print it out 102. It's a good idea for you to go through to make sure you understand the order of how these things ran, because that would be a very good question to know the answer to for a test.